Hi guys, I just wanted to go ahead and record this little video to give you a little bit more insight into our thinking process about interest. And so, of course, this is to be expected at the beginning of talking about interest. This always happens that we have a hard time thinking multiplicatively, or you can say multiplicatively if you want, about interest. And we sort of discussed or looked at a few different approaches that many of you proposed, which one of those was, okay, so we wanted to calculate the average earning, or we'll call it average profit, which remember, profit is just to find anything beyond what you actually spend. So if you invest $100, anything above $100 is your profit, but that base of 100 is basically your sort of not even your cost, but it doesn't, you already had it, so you didn't really earn anything by getting that $100 back. So average profit, remember, this is measured by dollars per year. So we want to basically take our dollars that we've earned and divide that by the number of years, and that will tell us roughly what we've earned over the course of that year. So we know that in this particular instance, if we have a present value of 100 and an APR of 12% compounded monthly, that would mean that we could calculate future values by taking the present value times the monthly growth rate. Well, if it's 12% compounded monthly, and you do the decimal form divided by 12, that gives you 0.01, and this is per month. It's not, I can't say percent. I mean, if we do 12% over 12 months, this is just 0.12 over 12, then you can say that this is 1% per month, like that. Or you can say 0.01 per month. All right, well, that means that our growth factor is 1.01. Remember, the thing we multiply by is called the factor. The actual amount of additional basis is called the rate. So we have a 1% monthly rate. And if we looked at this 2 years down the line, well, 2 years down the line, that would mean that I have to apply the monthly rate 2 times 12 times, which this is 2 years times 12 times per year, be 24. So now I'd come into my calculator and figure this out. 100 times 1.01 to the 24th power, and what do I find? I find that I should have $126.97. Okay, perfect. $126.97. Wonderful. Okay, so I can figure out, I see probably pretty quickly that the difference between my present value and my future value is, let's see, future value minus present value will tell me that I have earned about $26.97 in profit. And if I relate that per year, dollars per year, well, what do I get? Well, $26.97, that's dollars, divided by 2, which is the years that I earned this over, would come out to, well, let's see, I'm going to subtract 100 from that so I don't have to type it in, divided by 2 would give me $13.49 per year. Okay, well, you could probably agree with me, hopefully, that you didn't earn $13.49 the first year and $13.49 the second year. This is merely an average rate of change, average ROC, I'll write. This is just an average rate of change. Now remember, average, if we looked at this graphically, well, since this is growing exponentially, we're going to encounter something like this. But if we literally take the two balances, let's say at time 0 and 2, and we find the slope or the rate of change between them, now we are probably looks a little bit different than I've drawn it here, but we are probably actually undercutting it in certain parts and overestimating it in other parts. Now if you think of derivatives, yeah, at some point the slope is about the same, but eventually the slope starts to get bigger and bigger. But enough of that. So let's actually figure out how much of that $26.97 was earned in the first year and in the second year. Well, that should be a pretty easy calculation. Let's just take 1.01 to the 12th power and see what we would have after 1 year. Well, after 1 year, we could figure that out. We could come back over here and say 100 times 1.01 to the 12th power, excuse me, not to the second power, to the 12th power, and we get $112.68 as the future value. Okay, so the future value and the present value, we notice that the difference between those, F minus P, is going to be $12.68. Well, $12.68, that is over the course of 1 year. So in fact, over the first year, over the first year, I earned $12.68. So this is just the average rate of change over year one. Okay, well, let's compare that back to the number that we got before, which was $13.49. So what does that tell us? Well, that tells us that, as we see here, that the rate of change is growing faster and faster, and that during year two, we're probably going to experience a little bit more change. So if I take $112.68, and I take that 1.01 to the 12th power, so take that for another 12 months, I get the 126.97, and I notice that I guess I really didn't need to do this. I could have just taken 26.97, which is what I earned over 2 years, taken away what I earned over the first year, and that's $14.29. Okay, so what's your point, Milos? Well, my point is that a 2-year investment that has a $13.49 average per year does not necessarily result in that being the total, that being the true rate of change from one year to the next. So let's write year from 0 to 1. What did we say? It was $12.68. But for years 1 to 2, it was actually, let's see, a little bit higher, right? $14.29. Now, if you did take the average of these, you should get $13.49. If you sum them up and take the average, you get $13.49 because that's exactly what we got before. But notice this isn't evenly distributed. So this maybe isn't a great descriptor because, if you did this for 100 years, you'd find that your 100-year annual average might be something like $15,000. Well, but that doesn't really reflect what happens over the first maybe 30 years. Over the first 30 years, you may only earn a few bucks, but it's later on where that impact of bigger balance means bigger interest, that's when it takes place. Now remember, this is all interest, and this interest is based solely on whatever the current balance is. Okay, so this is just a nice rough way to describe your balance, but really we should be thinking about percentage change. Well, why percentage change? Well, because when you're dealing with exponential, anytime you're multiplying a balance, let's say 100 by 1.01, you're multiplying it. You're making it multiplicatively bigger. You're not just adding $12.68 or $13.49 each year. You are multiplying by something that makes your current dollar amount 1% bigger. Now, 1% is relative to how much you have, right? Because if it's 100, 1% is $1. But if you have 10,000, then 1% is what? 1,000, right? If you have 10,000. So in percentage change, we could actually look at over the full course of 24 months, which is what we did in class. We took 100. I'm sorry, we already know this answer, right? The answer is 126.97. So 126.97. Okay. Well, if we take 126.97, that's our present value, our future value, and if we divide it by our present value, which is $100, we can get the percentage change. Okay, so 1.2697. Well, what does this mean? This means that 126.97 is 126.97% of 100. Okay, so that's no surprise because we chose such a nice base starting number that literally what we're looking at is the percent. Well, that also means that the future value is 26.97% larger than the present value. Okay, so that must mean that what I'll call my 2-year yield, the percentage that I actually yielded relative to my present value, because that's what I'm doing. I'm comparing my 2-year amount to my 1-year amount, so that must be the 2-year change. The 2-year yield, we often use the word yield instead of change in finance, is 26.97%. Okay. Well, that's the 2-year yield, but what is the 1-year yield? So a lot of us are tempted, or we're tempted to just take 26.97% and divide that by 2 years, because it's natural to think, Well, that's percent per year, and that makes total practical sense, right? But unfortunately, mathematical sense doesn't work out to be quite that. So we're saying that you're actually growing by 13.485% per year. Now that's an average. This is really literally an average, right? An average rate of change. Okay, sure, that makes sense, but now let's see if I actually applied, let me see, what was that again? 13.485. So if I took my $100 and I multiplied it by 1.13485, so 13.485% per year, and I did that for 2 years, I should get what? Well, I should get $126.97. Should get. But because I took something that's multiplicative and I split it into two things, I'm probably not going to get that. Watch, 100 times 1.13485 to the second power, and I get $128.79. Now you might think, oh, that's just rounding error, but that's actually almost the 2% error that we're getting, and that's 2% error is pretty big to be dealing with rounding. So I almost have a 2%, a little less than a 2% error. So what's the issue here? Well, let's just look at the 1 year yield for a second. Okay, so if I take 100 times so back to the monthly, we're going to cross this out because we shouldn't just be dividing percentages by 2 when we're trying to calculate your actual annual yield. Okay, so 100 times 1.01. Let me just look at this after 1 year. Well, we calculated that's $112.68. We also know that we started with $100, and if I take my new balance, so from year 1 to 0 to 1, and 1 to 2 would be, now my balance is $112.68, and I'm going to grow that by 1% 12 times to get me to year 2. That's going to give me the $126.97. So I should be able to figure out what the annual rate is. Well, if I look at, and this is probably a little bit easier than what we did in class. I try to imply this, but I think we were just beyond that at the moment. But if I take the ratio of these, if I compare my future value after 1 year to my present value initially, guess what I get? 1.1268. Ah, okay, so wait a minute. The actual growth rate from year 0 to year 1 was 12.68%. I'm going to use an arrow because I'm going to take off the 1 and just say 12.68% APY, annual percentage yield. Okay, well, is that true? Did I not just find another average? I mean, it's not. It's obviously 13% is a little bit high, quite a bit higher actually than 12.68%. But is this a true number now? Well, let's see. If I now take the 126.97 and I divide it by what it was 1 year previous, which is 112.68, guess what I'm going to get? Not surprisingly, comparing the next year to the previous year is always going to yield 1.1268. And that again implies a 12.68% APY. So my annual percentage yield is actually a little bit easier. I don't have to actually do any roots or anything like that, because from 1 year to the next, my percentage change will actually be the same. So 12.68% APY. And let's just verify this. What we're going to do now is say, okay, well, let's just double check. If I take 100 at 12.68%, my annual yield, and I do this for 2 years, I should get $126.97. Let's check that. 100 times 1.1268 to the second power. So I'm taking my annual growth rate, my growth factor, and squaring that, and look at that, $126.97. Ah, so this is the true percentage yield. Whoops, it's getting sloppy here. And percentage yield per year. and there was no division involved here. We get the true value this way. Now, it doesn't really matter, long story short, how you calculate that APY, whether you compare what you have after year 1 to what you started with, or whether you compare year 2 to year 1 or year 3 to year 2. As long as you're looking at just a 1-year period, the ratio of new to previous should always give me 12.68%. Beauty. So that's an exponential function. That's exactly what we mean when we say exponential function. That the ratio from the next to the previous is always the same. Okay, so that illustrates the idea of APY. So APY really is the future value after 1 year, or one way to calculate it, divided by the present value at year 0. Take away that 1, of course. I mean, you don't have to write it this way or think about it like this, but you're going to get 1.1268. So if all you're interested in is the actual growth amount, that's the 0.1268. All right, and finally, let's tie this in. Okay, so remember our APR was 12% APR, and it was divided up, and it was paid at 1% compounded monthly. Now, in reality, there seems to be a contradiction here, because what we actually yielded, or what we actually earned, was 12.68%. So did we just play a trick on the bank? Is the bank really losing money on us? Well, oftentimes, banks seem to be reporting more and more the APY instead of the APR. Why? Well, because it's a little bit bigger. And at some point, banks realized, hey, we could probably get a little bit more business by showing them what the actual yield is instead of the APR. Well, why do they show you the APR? Oftentimes, people or investors are interested in how often interest is paid, because if interest is only paid once a year, that means, at the beginning it deposits something and then you get interest 1 year later. That's going to be more of a long-term investment that an investor who's trying to turn around a big profit in a short amount of time would want. So who would want to wait a year before interest would pay? And so some pay monthly, some pay daily, and it does make a dollar-wise difference. So this idea, this discrepancy between APR and APY, why is it? Why is this happening? Well, I'll let you think about this, and this is the first question I'm going to ask you on Wednesday. Why is this happening?